Next, then the dew point temperature. The dew point temperature is temperature of air is reduced by continuous cooling, and then the water molecules in the air starts condensing, or the temperature at which the water molecules in the air starts condensing is known as the dew point temperature. That means if you are continuously cooling, right, and it starts condensing, if you cool air and continuously if you cooling, what happened? The air is again starts to water, right, condensing. At what temperature the water gets ice? 0 degrees generally, or maybe if you want to get a steam, then you have to boil the water at 100 degrees centigrade, and this water continuously cooling, then it starts condensing. That means it starts drop by drop. Condensing means totally it is condensed. That point is called the dew point temperature. Okay. Next, then the absolute humidity. The weight of the water vapor present in unit volume of air mixture is known as the absolute humidity. Next slide. Then the specific humidity or humidity ratio. This is a mass of water vapor present per kg of dry air. That means if you take 1 kg of dry air, then what is the water content in that? That is called the specific humidity or the humidity ratio. It is the formula simply mass of water vapor. It is the ratio of the mass of water vapor in the mixture to the mass of dry air in mixture. Simply mv, it is the mass of water vapor, by mu, that is the dry air. It is equation 1. Next slide. Therefore, again in the previous formula, MA by MV, that MA is, you know, PV is equal to MRT formula. In that, if you substitute that, classify this MA is equal to PV by RT, and same thing MV. And where this PA is the partial pressure of dry air, V is the volume of the mixture, this is RU is the characteristics gas constant for dry air, which is equal to 0.287 kilojoules per kg degree Kelvin. I think normally generally we take the R value. R may be 287 joules per kg degree Kelvin. The PV is the partial pressure of the water vapor, and then RV is the gas, that is characteristics of gas constant of vapor, which is 0.462 kilojoules per kg degree Kelvin. Next slide. But this RU is equal to K by MA and RV is equal to K by MV, where the K is the universal gas constant 8.3143 kilojoules per kg mole, and this M directly MA and ME are the molecular weights of air and water vapor. Next slide. Like that, you substitute these values in the previous equation 1. Therefore, the specific humidity, finally, MV by MA, you substitute the MV and MA. Next. So this is finally you calculate all these things, then we will get finally next slide. So this is the specific humidity or humidity ratio 0.622 PV by, this is the PT minus PV. This is finally we will get the formula, and therefore if you know the partial pressure of water vapor and then the one PT, then we can calculate the what is it? Somebody is typing, Okay, so then this is the way to how to calculate the specific humidity. Then next, then the relation between the mass and a specific volume, M A is equal to V by VA and ME is equal to V by VB. So V and V is the specific volume of dry air and water vapor, and where V is the volume of the mixture. Next, then the degree of saturation, the ratio of mass of water vapor associated with the unit mass of dry air to the mass of water vapor associated with the unit mass of dry air saturated at the same temperature and pressure. This is the dry air, it is denoted by the mu. Next slide. Water unnaya? So this formula simply, mu is the mass of water vapor associated with the unit mass of dry air by the mass of water vapor associated with the saturated unit mass of dry air. Simply, relative humidity, that is the mass of water vapor in a given volume to the mass of water vapor in same volume if saturated at the same temperature. So this is denoted by the phi, the relative humidity. Next, so this is the way how to derive this equation. This phi is equal to mv by mvs, where m is equal to already we know earlier, and finally this is equal to the relative humidity is the PV by PVS, where the PV is the partial pressure of water vapor and partial pressure of the saturated. Therefore, finally, this phi is relative humidity is equal to degree of saturation finally. Next, then the enthalpy of the moisture air, it is the enthalpy of moisture air is equal to enthalpy of 1 kg of dry air plus enthalpy of water vapor associated with 1 kg of dry air, simply, and by mathematically H is equal to HA plus, this is the relative humidity into enthalpy of dry air. So this is the formula. Generally in thermal engineering we have to calculate some, if the dryness fraction is 1, H is equal to simply HS, or if it is a wet steam then H is equal to HW plus XL, like that. So this is the formula, where HA is the enthalpy of the dry air. Then this omega and HV is the enthalpy of the water vapor associated with 1 kg of dry air, and with this formula you can calculate the enthalpy of a moisture air. Next slide. Considering the change in enthalpy of perfect gas as function of the temperature only, enthalpy above a datum of 0 degrees centigrade can be expressed as, this is the enthalpy can expressed this formula, and where this CPA is the specific heat of dry air, kilojoules per kg degree Kelvin, and then the CPW is the specific heat of liquid water, kilojoules per kg degree Kelvin. This value is equal to, it is a fixed value 4.18 kilojoules per kg degree Kelvin, and this is the TDP, that is the dew point temperature. Already have seen in the previous slides the dew point temperature in kilojoules per dew point temperature in degree centigrade of the air. Then the TDP again dry bulb temperature, TDP it is TDP. So dP is the dew point temperature, dB is the dry bulb temperature of the air at 0 degrees centigrade, and this is the HFG, dP it is. I think you know the HFG, right? What is HFG? Latent vaporization at dew point. I think earlier we have calculated in the steam problems, HFG is the enthalpy of the, that is latent heat actually, enthalpy of the liquid plus vapor, HFG value that HFG plus HW is equal to, you can take as a HS value earlier in your previous thermal engineering too. If you want to calculate the enthalpy of a wet steam or maybe dry steam, wet plus dry you can calculate a HS value. Like that, this is HFG. F is the fluid and G is the gas. HFG means the mixture of water plus vapor. That's why it is HFG, latent heat of vaporization. And then CPV is the specific heat of a superheated vapor in kilojoules per kg degree Kelvin, which is the 1.88 kilojoules per kg degree Kelvin. Next. Finally, this H is equal to, if put in this formula, we will get this equation finally. That is the specific heat, and then the dry bulb temperature. This is the value of the specific heat again, then the dew point temperature, then this is the latent heat. Like that we can get finally the enthalpy of the moisture air. Next. Then the psychrometry chart. Already you have seen the psychrometry, right? Then the psychrometry terms also have seen. Then this is the psychrometry chart. So this is the psychrometry chart. I think it looks like, it is also called, how it is looking? Shoe. Generally we are using shoes. Then this is also called shoe chart. Okay? And here we'll clearly give one by one. So this is the saturation line, is total, and then these are the relative humidity lines, and this is the specific volume lines. This is the wet bulb temperature line, and this is the dew point. From this the condensation starts. That's we have clearly seen in the dew point temperature, right? And then this line, the vertical line is called the dry bulb temperature line. Okay? So this is a specific humidity, which is W, small w, and then water vapor present, which is a small FW. So this is actually dry bulb temperature, this one. This is psychrometry chart. Next slide. So, if you, one by one if you see, the psychrometry chart, the dry bulb temperature is the commonly measured the temperature from the thermometer. In this, the vertical lines indicates, suppose here some 5 degrees, 10 degrees, 20, 25, like that. This is the increasing order, the temperature in degrees centigrade. The vertical line indicates the dry bulb temperature. Right? The next slide. Then the psychrometry of wet bulb temperature, where wet bulb temperature is determined when the air is circulated past a wetted sensor tip, intersection of dBT and that is dry bulb temperature and wet bulb temperature provides the status of the point. Suppose if you want the dew point temperature somewhere, this point, these two are coincides. This point is the reference point, where this lines, inclined lines are called the wet temperature. Suppose if you want remaining all the points, if you know the dry bulb temperature and the wet bulb temperature, suppose say the dry bulb temperature is 25 degrees centigrade and the wet bulb temperature is some 19 degrees centigrade, where these two are coincides, then you take that point, suppose say somewhere this one. This is the point, difference point, and from this point you can say what is the specific volume, then what is the relative humidity lines, maybe somewhere these two are coincide somewhere here, suppose. So from this point what is the specific value, the relative humidity lines, and then what is specific humidity lines. You can say all this once you know the 2 points. So these inclined lines are called the wet bulb temperature. The next one. In the saturation line, this is the saturation line, already I discussed about this, right? The saturation line is a temperature condition at which water will begins to condense out of moisture air. It is also called the dew point temperature of line. So from this point, this is the point is called the where these wet bulb and dry bulb temperature coincide at this. This point is called the dew point temperature. That's why it is a saturation line also is called the dew point temperature line. Next. Then the relative humidity lines, already we have discussed it. The relative humidity line, it is RH, is a ratio between actual moisture content of the air compared with the moisture content of the air required for saturation at the same temperature. So this is the lines 30%, 40%, 50%, like that. So this saturation line is the 100%. So this side it is what is it? 100% humidity means moisture content is more. So beyond this saturation line, this region is called, we have seen three regions. One is the liquid region, one is the liquid plus vapor, one is the total vapor. Right? So this is your saturation line. If you are coming to this side, left side, it is a liquid region. That means it starts to condense. That point is the saturation line. After that, maybe this is totally, it is liquid. Okay? Next. Then the specific volume lines. This is all in the only single graph. These specific volume lines. Then the dry bulb temperature line, wet bulb temperature line, relative humidity line. Same in the only one graph. That's why clearly I am showing all these. The specific volume indicates the space occupied by air. This is useful in converting volumetric flow of the mass to mass flow rate calculation. So this is the kg per meter cube per kg. These are the, at this particular point, if you know a point, from that point you can say what is the specific volume of that, and what is the dry bulb temperature, and what is the wet bulb temperature, what is the enthalpy. Right? All these things if you locate one point, but you should know some at least 2 or 3 values. Next. Then the enthalpy. I think you know the wet bulb temperature lines already. Inclined line. This is the enthalpy. So this U line extend after this saturation line. These points are the enthalpy lines. Enthalpy is the energy content of dry air and moisture expressed in kilojoules per kg of dry air. The information is useful is sizing of heating and cooling coils. At the enthalpy also we can calculate with the help of these points. So see this arrow, this is the enthalpy increasing. Okay. Yeah, then the sensible heating process. Heating means these lines are called, vertical lines are called dry bulb temperature lines. If it is increasing, then it is called, from this point, suppose if you take this point, if it is point from this point, if it is right side it is increasing, then it is sensible heating. And it is opposite side is called the cooling, sensible cooling. I think already we have discussed it. This is the liquid region, this is the vapor plus liquid region, and this is the vapor region. So from this point, if you come into the left side, then it is a cooling, that is sensible cooling. And then it is right side, then it is the sensible heating. Heating is cooling because the addition or removal of sensible heat without changing the absolute moisture content. But the relative humidity changes as the temperature changes. Next. Then the dehumidification, heating, cooling. Then the dehumidification. See, this left side automatically cooling and dehumidification. Heating and humidification, right side suppose. This line, suppose, it started from the left side. That means this is cooling and dehumidification. Then suppose if it is coming this side, then the cooling and humidification. Humidification means humidity. Dehumidification means reducing the humidity. Next slide. So this is a common total graph of your psychrometer. Alright. In this maybe all lines are included. That is this is the curve lines. This curve lines is called relative humidity lines, and these inclined lines are called the wet bulb temperature lines, or if you extend it is enthalpy line again, and these vertical lines are dry bulb temperature lines, and these horizontal lines are where these two coincide. This is called the dew point temperature. This is the specific humidity. So this is the total graph, and this is the comfort zone. Right? Comfort means human comfort. Generally, we talk about human comfort. Now we are sitting in a comfortable position or not? We are not comfort now. Right? Because there are some parameters. Comfort conditions means that already have seen the temperature and the humidity, airflow, and then purity. These are the comfort conditions. So a human being, if you follow these values, then it is called the human comfort. Right? See, this region, are you visible it? This is the region, the comfort zone. If you take these values, this is the value, then the comfort zone it is. Next. The comfort zone is, statistically majority of the human beings are comfortable when the temperature is between 18 degrees centigrade to 22 degrees centigrade, and the temperature, that relative humidity is 40 to 65%. This is the comfort zone. So in the competitive exams also, the temperature, the dry bulb temperature, this temperature is dry bulb DBT. The comfort, when the temperature, what temperature it is? Dry bulb temperature. Dry bulb temperature, it is between 18 to 22 degrees centigrade. Between these two, this is 18 to 22 degrees. Is the, in the previous graph also, previous graph, this one, this is the 18 to 20 degrees. This zone, I am highlighting the next slide. This one, this is the comfort zone, 18 degrees to 22 degrees centigrade. This is the WBT, not WBT, DBT, dry bulb temperature. And then the relative humidity, this is the 40 degrees, 40%, and then this is the 65%. This line. Between these two, the value is the comfort value. Our temperature also, between these two, is the comfort values. That's why the comfort conditions, that is human comfort conditions, are 18 to 22 degrees centigrade, DBT, and the relative humidity is 40 to 65%. Suppose a question is like this, calculate the following, that is enthalpy, specific humidity, specific volume at comfort zone. Suppose say it is 21 degrees centigrade DBT and the 50% RH, suppose. Then you mark that point exactly. I am giving 21 degrees temperature. Say somewhere this point, you make it, that is this point, 21 degrees, and say this is a 50 degrees, 50% relative humidity. Then from this point, you can calculate all the remaining things. What is the specific volume? What is the enthalpy? And what is the WBT also you can calculate. And then what is the specific humidity ratio also you can calculate. Right? So this point comfort conditions are say 21 degrees DBT temperature or 18 to 22 means if you add these two and divide by 2, 18 plus 22 by 2 means 20 exactly. Okay? And then 50 degrees or 50% or something RH, then you calculate the remaining things. Next. So this is the climate classification. These are the comfort zone. The color is some light blue and then blue, then yellow, this is somewhat red. This zone is called the comfort zone. The climate classification shows the various approximate zones of temperature and humidity on the psychrometric chart. This comfort maybe depends upon the area, depends on the climate. Next. Then heating C. So heating without humidification at a C, this arrow at a C means maybe the temperature, there is a liquid region, right? C means liquid region, that's why the temperature is maybe increasing, heating at C. Okay? Next. Then psychrometric, heating at a C and humidification also. Earlier without humidification, right? It is something horizontal line, but this is called increasing means humidification it is. If the arrow is downwards, then it is dehumidification. Are you following or not? Next slide. This is the heating process in detail. Process shows the sensible heat addition. This is the simple heat addition, and this is the heating and humidification. Right? Next. Then the dehumidification, already I told, this is called the cooling and the dehumidification. And from this point is called the cooling and the dehumidification. Next. Then the psychrometric chart is prepared to present graphically all the necessary moisture air properties. Next. It gives, the psychrometric chart gives the specific humidity, the relative humidity, the specific volume of the air, enthalpy of the air. I told you, no, at a particular point, you can calculate all these points. With the reference of that point, you can calculate this in a psychrometric chart. Next slide. So this is the psychrometric chart. Maybe some calculations we will see. Next. This is a, tell me now, this is what? Cooling and dehumidification. 1 to 2, it is cooling and dehumidification, then the value, enthalpy value it is. This is the temperature, T1 and T2. T1 is more than T2 because this is the dBT line. Then this is the W1 and this is the W2. Then it is H1 is equal to H2. Next value. Next slide. Then I take a problem, all of you. A sling psychrometer rates the sling psychrometer reads 40 degrees centigrade dBT and 28 degrees centigrade WBT. WBT means wet bulb temperature and the dBT is the dry bulb temperature. Then calculate the following all. Calculate the specific humidity, the relative humidity, the dew point temperature, enthalpy, the specific volume per kg of dry air. Assume the atmospheric pressure to be 1.03 bar. Almost all psychrometric charts are prepared with this pressure. Atmospheric pressure is I think you know the formula, partial pressure of water vapor. this is finally in this formulas P partial pressure of water vapor is 0.0299. Simply you can take this value is round value, it is 0.03 bar. Next. Therefore the specific humidity 0.622, already this formula we have seen previously, and then you substitute the values. Therefore the specific humidity is 0.0186 kilojoules kg per kg of dry air. Next slide. The relative humidity according to this formula PV by PVS at 40 degrees centigrade is the value is 40%. The same at 40, come to the problem again. Yeah, this is the problem. So you practice at home. You take this psychrometry, locate the point where this 40 degrees and 40 degrees dB and 28 degrees WBT, where these two are coincide, and that is the reference point you take. Then to calculate this all, I think it is easy. It is graphically you can calculate. And here assume the atmosphere pressure 1.03 bar given. It is analytical. Yes. Next. This is the analytical problem. All. Next slide. This value you compare with that. It should be maybe more or less 10% or more or less. You should get the relative humidity is 30%. Then previous slide. And the specific humidity is the value it is 0.01866 value. Compare with the psychrometry chart with the analytical value.